Hi there, so today we're looking at the topic of probability, and when it comes to AS and A-level maths, probability is just about the one topic where things don't get much trickier than what you would have met at GCSE. True, we will bring in things like interpolation into play as well, but altogether I don't think you'll find it too bad. In fact, we're going to start with a very simple example. Okay. Have a go then at this little question about a couple of spinners. Right, so there's more than one way you can come up with it, but you've got two fair spinners being spun. The results is recorded, and the sum of the results is recorded. So we need to think about what they would add up to. Both spinners can go up to 4. So I've got one spinner going one way, one another way, and we could just use a little sample space diagram to show that. This would, if they both got a 1, I could get a 2, a 3, a 4, or a 5. And that goes on, and we get a nice little pattern of numbers going on like this to 7, 5, 6, 7, and 8. So the probability that we get exactly a 5 is, well, we've got 1, 2, 3, 4 5s out of, well, there's 4 by 4, there's 16 numbers there altogether. So you could say it's 4/16, or you could simplify it to a quarter. More than 5 is these 3 6s, the 2 7s, and the 1 8, which are 6 results. 6 results out of 16, which is the same as 3 8ths. Okay, here's another problem. The first part's simple enough. The second part, you'll need a little interpolation. Pause the video and give it a go. Right, hopefully you could read what it was saying there. So the time taking less than 9 minutes, well, that's clearly these 19 here, the 6 there and the 13 there. So that would be 19 out of however many students we've got. So we've got 19, 31 plus another 9 makes 40. So 19/40ths for part A. For part B, 10.5 students is somewhere in here, isn't it? Now the group width there is 2. So out of 2, we just want from 10.5 up to 11, which is 0.5. So 0.5 over 2, which is the same as a quarter, multiplied by how many are in that group. So we want a quarter of that 12, which is 3. And then we would be adding on the 5 there and the 4 there. And that would give us 3 plus 9, which makes 12. Okay, we're going to move on to a couple of other problems now. Before we get on with this next question, I've just realised I just said the answer was 12 on that last one. Probability can never be more than 1, can it? It was 12 out of 40, which is equivalent to 3 over 10, isn't it? Yeah. Anyway, carrying on, pause the video and have a look at this koala problem. So, the probability that the koala is female. Well, first we need to work out how many females there are, and then how many there are altogether. Now we do know that there's 240 altogether, so we could just say 114 over 240. Stick that in your calculator and press equals, and it'll simplify it for you to 19/40ths. We could double check we're right, of course, by adding up how many males we've got, which is 126, and checking that adds to 240, which it does. Now the probability the koala is less than 80 centimeters long, so that means all of these ones up here, 14 plus 15 plus 32 plus 4 plus 20 plus 24, and they all add up to 109 out of 240. Then, what's the probability the koala is a male between 75 and 85? So that is these ones here, isn't it? Between 75 to 80 and 80 to 85. add those two together and you get 71 out of the 240. Now it gets a little more interesting on here where it says 72 centimetres and or less than 72 are juvenile. So we need to estimate that probability. Well, we've got all 4 of these are going to be juveniles and those 14 there. So that gives me 18 plus I've got 35 there, but we need to do a little interpolation for these 35. The group width is 5, but we only want the first 2/5 of them. So that's what I'm going to whack into my calculator, which gives me 32. So then we're looking at 32 over 240, and that's going to simplify to 2/15. There's nothing to be gained, by the way, by going into decimals, especially there, because 15ths will be some kind of recurring one. Okay, and we also need to state one assumption we've made in making our estimation. Well, that's all to do with this. We're assuming that they are uniformly distributed within that 5 centimetre range. So there I've just written something along those lines. I've assumed that the koalas are uniformly distributed in the 70 to 75 centimetre group. Okay, histogram next. Give this one a go. So, frequency density goes up the outside. What you need to remember with a frequency, with a histogram, is that the frequency is the area under the graph. So we've got here a width of 1 and a height of, it looks like 22, or is it 24? Yeah, there's 5, 1, 2, 3, 4, 5 going up there, so that is, so 24 high. So the frequency there is going to be 24 times 1, which is 24, and then this is 2 wide, and that's 4 up, so 4 times 2 is 8, giving us 32 cats out of the 70 cats that we had. So the probability is going to be 32 out of 70, which simplifies to 16/35. Okay, estimate the probability a cat chosen at random has a mass less than 6.5. So this is going to need a little interpolation of a kind, isn't it? So we know that there are 70 altogether, probably quicker just to find out how many are in that zone there. So in that zone there, it is 3 wide, no it's not, it's 1.5 wide, and we're multiplying by the 4 high that it is. So that gives us 6 cats in that zone, but we want all the ones that are less than that. So 70 take 6 is 64, so we should have 64 out of 70, which is exactly double the other one, isn't it? So that should give us 32 out of 35. And finally, we've got a problem that you are going to want to pause the video and spend some time thinking about this. Don't give up immediately and just watch me bumble through how to do it, because that is what I'm going to do. I'm going to take my time and try and think it through as I would do if I was suddenly faced with a poser like this in an exam. So pause the video, give it a go. Right, so what have we got? We've got the fact that she records the product of the 2 cards, one from that group, one from this one. So that is what you get when you multiply them together. So I know that if I just were to make a tiny little two-way sample space diagram here, my answers would be 8, 28, 5 4s are 20, 2x, 7x, and 5x. So I've got 6 possible answers. They're saying the probability that it's even is the probability that y is bigger than 20. Now I know that it is not possible for, or what I know is that there is at least one that's smaller than 20. So what that means is x cannot be even. Because if x is even, the probability that y is even would be 1. And the probability that y is bigger than 20 is not. So for this reason, I know that x is odd. Now, the other thing is, if this is going to be the same, if the probability is going to be the same as that, it cannot be a number so big that 2x, 5x and 7x are all bigger than 20, because that would give me why can't it be that? Because that would give me a 1. I said I was going to bumble through, and I will. Right, yeah, so what we're thinking about is that we've got already one chance there. Now, if x is big enough that two of these, that all three of these make more than 20, then the chance of it being bigger than 20 is 5 out of 6. Whereas the chance of it being even will not be. And the reason it won't be is that if it's odd, an odd number times an odd number is odd. So 7x is odd. 5x is odd. The others are all going to be even if it's an integer, because you times an even by 2 and it's going to be even, isn't it? So this means that the probability y is even, I know, is going to be 2 out of 6. I'm not going to change that into 1/3 because this is the important bit here, isn't it? So what that means is that the probability that y is, that's even. So the probability that it's even is not 2 out of 6. Those two will be odd. So you're going to get 2 out of 6 it's odd. You're going to have 4 out of 6 that it's even. So if it's 4 out of 6 that it's even, the chance that y is bigger than or equal to 20 is also 4 out of 6. So what does that mean? That means that these two must be bigger than 20 or equal to, and this one is smaller. So we're looking for an odd number that makes 2x less than 20. So we could have 2 times 1 is 2. We could have 2 times 3 is 6. We could have 2 times 5 is 10. We could have 2 times 7 is 14. We could have 2 times 9 is 18. We can't have 2 times 11 is 22, because that's too much. Now that's true, but the other thing that we need to be aware of, that 7x and 5x, if we're only going to have 2 of them being less than 20, 7x and 5x need to be at least 20, don't they? And 5 times 1 is only 5, so that's not enough, so the 1s can go. 5 times, I'm only considering 5 because it's smaller than 7, so as long as we sort the 5s out, the others will be okay. 5 times 3 is 15, that's too small. 5 times 5 is 25, that's okay. So 5, 7 and 9 are going to work. So the possible values of x are 5, 7 and 9. If that confused you, pause it, go back, just look at it again and work through it again until it makes sense for you. Alright folks, cheerio, until next time.